C1 Algebra GCSE Review Example 1D. This is the trickiest of the four parts to this example. We are substituting in an x value of a plus h. So when we sub this into f of x, what we end up with is f of a plus h. The number in the whatever's in the brackets here is what we call the input to the function. So we're inputting a plus h into this function. Now this function squares the input. So if x was the input, this function squares it, then multiplies that by 3, and it takes away the input. So this time our input is a plus h. So that needs to be squared. So I need to square all of a plus h. So I need the brackets. Then that gets times by 3. And then I need to take away the input again. And this time the input is a plus h. If I stop there, that is wrong. I need to take away all of a plus h. So the a plus h has to go inside brackets. Without them, it's wrong. Like I did on a previous example, I'm just going to write this out again without brackets to explain why it would be completely wrong. So if I didn't write any brackets here, this is wrong for a number of reasons. First of all, only the h is being squared here. But we don't want that. We want all of a plus h to be squared, which is why we need the brackets. Another reason this is wrong, like I mentioned before, here we're taking away a and then adding h, which is wrong. We need to be taking away all of a plus h. I'm going to expand these brackets just to once again show why this would be wrong. So if I expand those brackets, I'm going to leave the first ones alone for the moment. The second pair of brackets have a minus 1 in front of them. The 1 is just invisible. In maths, we don't bother writing that 1, but it's there. It's just invisible. So everything inside this bracket is times by minus 1. So we've got minus 1 times a, which is minus a, and then minus 1 times plus h, which is minus h. And again, you see how these two are different. This one is correct, this one is incorrect, because they're different. Now, the first pair of brackets, I'm going to expand these, and this is going to highlight a common error. You might think that squaring a plus h gives us a squared plus h squared, but it doesn't. Let's recap what we mean by squaring. When we square, we multiply something by itself. So here we have a plus h times by itself. So I'm going to write it out in that way. A plus h all squared means a plus h times by itself. I'm going to put the extra terms in now, just so that what I write here is still equal to the line above, because I put an equal sign there. It must still equal the line above. Now from GCSE, you might recall something called FOIL or smiley face method. There's lots of different methods. Whatever you use to expand two brackets, that's what we need to do here. So I'm going to expand these two brackets. So a times a, I'm going to do that one first. I get a squared. In the middle, a times h. On the outside, another a times h. And then h times h, which is an h squared. Now once again, brackets are important because all of that was times by 3. Not just the first bit. If I leave it like that, that would be wrong. All of it is times by 3. All of it is times by 3. So I need 3 times all of it. And remember the bit at the end as well. Don't ignore them. Because once again, whatever we write down here must still equal the line above. I'm going to do one more thing here, and that's collect these like terms and expand this bracket, because everything inside here is times by 3. So I've got 3 lots of a squared, which is 3a squared. I've got ah plus another ah, so that's 2ah, and then times by 3. So that's 6ah. H squared, which is times by 3, so that's 3h squared. and remember the ones at the end. So every single line here is equal to the one above. My last line is equal to the previous line, which is equal to the previous line. These are all just different ways of writing the same thing.